This is the introduction part of the new overhauled series on how to build an RTS inside of Godot using only Gdscript from scratch. We'll be covering how to build RTS mechanics in order to have a minimal viable product similar to a traditional RTS. So this is Star Wars Galactic Battlegrounds. Our goal is to build what this game offers us. The idea is not to actually clone this game, but rather to make use of it as a reference material so we can actually build our own games. So on my previous attempt at this series, I actually did a lot of experimentation. So all of those experiments actually have impacted this series along the way, and I saw many people struggle with it. Not a great experience overall. And this new one will be based on 3 important pillars, which are consistent throughout the videos, simple as possible, and let's complete a minimal viable product. Resource files and assets will be available for free in the main project Google Drive link for this channel, which you can find more about in the community tab of this channel as well. If you wish to support this series or get access to the project files, consider supporting on the current available platforms. Let's see how we're going to be building this inside of Godot. So this will be the goal of the project on this first part. So let me just run the project. So as you can see, this is what we will be building from this video part 1. So let me just fire up my desktop and let me actually open Godot here. And of course I'm using the one with the terminal so I can see stuff that happens. So this is the first screen you're going to see, and this will allow you to basically edit your projects inside of Godot. So I'm going to be creating a new one. So let's go ahead and create a new project. So this will be an RTS project, and I'm going to be actually now selecting the folder to place it. So now that I have chosen a folder to place the project, I'm going to simply do not create folder because the folder I have selected is already empty. So now you have given a name and a path for a project. Next, you select which render you want to use. And here we have a couple options. I'm going to be basically using the advanced one, which is the forward plus. Also, we will not be using any version control, but rather simple backup systems. So I am not using Git, so let's disable this. And let's leave edit now. So we'll be creating this new project. So let's go ahead. And there we go. We are inside a blank project inside of Godot. Let me just now toggle the full screen mode for this one. And here we are. Now the first thing I'm going to be doing is going ahead and creating a basic node for our world. So this node is going to be an empty node, and let's call it main. So now we have a basic root node for our main world. Now let's go right ahead and save the scene, and inside of our main folder, let's save this one as main. So this will be the main scene we'll be using whenever we run our game. So if we do that right ahead and run the project, it's going to say we don't have a main scene defined. So let's select the current one. So this will be the main scene we'll be running whenever we run our project. So now it's running on a separate window. I will be able to want this to be on inside of the editor. So I'm going to disable this option here. Whenever we run our project again, it's going to start now inside of the editor window, which is the thing I want. So now let's toggle the scale of this viewport so it actually stretches to your entire game space. So whenever I click that, now our window is stretched for the space we want, and this is the resolution it's using. All right. Now the first thing we will be doing is going ahead and adding a node to our 3D scene here. It's going to be a node 3D, which is going to be the basis of our 3D world. So let's go ahead and rename this node to be our world. And let's actually lock this node so we can no longer move it or rotate or do anything fancy with it. So it's going to stay put. And now let's add a simple mesh instance, which is going to be the basically plane of our 3D world. So let's go ahead and let's add a plane mesh. And let's put the size to be something actually quite big, like 250. And now we have a basically floor. So now for reference only, I'm going to quickly drag the icon inside of our 3D mesh plane. So it's going to be applied as a texture for it. So now if we select our plane and we go down here under geometry, we're going to see that it generated a basic material. And if we click under it, we'll see an albedo texture on it. which is something just for us to use as a reference. So let me go quickly here on the UV and set the scale to be something like 6. So we're basically scaling the UV of this texture so the texture repeats itself and we see something here. Okay. Now if we run our scene, we'll not be able to see anything because the camera is on the orange and it actually doesn't have a camera yet. So let's add our camera nodes. So I'm going to be adding a node 3D and a camera 3D. So now we have a camera and a node, and let me just increase the height of the camera. So let's put here 10, and now we have a basic camera system. Now if we click on our camera, we can see a preview of what that looks like. So whenever we run a scene, we're going to see what that looks like. So yeah, pretty bland. And as you can see, there is no light nor a sky. So to add those, let's go right here and let's add the sun to our scene and let's add the environment to our scene. So it generated those other two nodes, which I'm going to be placing inside of the world. And now we have a basic world 3D. So whenever we run a scene, by clicking here or press F5, you can see now the sky and it has some light under it. So now let's start by actually doing some stuff here to our camera. So now will be the moments I will be adding scripts and some logic to our camera and our main 3D world. So before we do that, I would like to add a script template to make a standard for every single script in our project. So let me show you what that looks like. So let's go ahead and add a new folder, which will be called script templates. And inside of it, I'm going to add another folder and call it node. So this will be a basic script we'll be adding to all other scripts to inherit from, just to use it as a basic template. So let's go ahead and add a new script there. Let's call this our basic custom script. And just click on create. Now if we open this, we're going to see our first script here. Let's double click on it and let's do some things here. So in order to make this script be recognized for Godot as a template, we're going to be adding some stuff here on the top of it. So this meta name refers to how this template will be called whenever we select on the new script tab. Here's the description for that template. Here is if we want to use this as a default script for whenever we create a new one, which is something I want. So I'm going to set this to true. And here you can overwrite the indentation spaces for the script. So overall, this is what we want. And now I'll be doing some modifications to the script. Let's remove these unnecessary comments here, which I don't want. And let's provide the structure we'll be using for this script. So we'll be actually building the template. Let's create some comment lines here we'll be using to separate our code into our main common functionality we'll be using for almost all scripts. So the first one is going to be enums, the second one will be constants, the third one is going to be exports, the fourth one is going to be public vars, the other one is going to be private vars, the other one already vars, the next one will be the built-in override methods, the other one is going to be public methods, and the other one is going to be private methods. So this basically is going to be the basic template we will be using, and I'm going to put an underscore here just to hide that highlight. So we have our template ready. Now let's go ahead and click on save, and now we have our basic template. So why I have done that? So here's why I have done this template. Let's minimize the folder, and now let's add a script for this main scene here. So let's click here to add a new script to that node, and let's call main, and it's going to be stored under our main res folder. And here on the template option, you can see there's a mark here, and we can now select our node-based custom script. And whenever we do a create button here, and now you can see we'll be using that template we assigned here for our new script. So we'll have this comment line built here, which we will be able to organize our code every time we build a new script. So pretty handy. So let's leave the script where it is. This is just going to be our main one there. So let's go ahead and save our scene. So now let's set up our Rts camera here. So I'm going to be renaming this node here as the Rts camera. And let's save this node and its children as a separate scene, so we'll be able to use it. So I'm going to be creating a new folder here, which is going to be called our RTS camera. So the way I'm going to structure this video, I think I'm going to use the organization of files based on assets rather than types. So there was a video discussion about this that I made and show you how you can organize your project by data type or by asset type. So the idea of this project is going to use the asset type. So we'll be developing assets and organize them by assets, not precisely types. We'll do a mixture of both when it makes sense, but for now let's do decouple elements such as the RTS camera. So now that we have a folder, we're going to be calling out this script as main. And we can also reset its position so it goes back to the origin of the world. Now we have our basic scene set up, and if we click here, we are now inside of the main scene that we're going to be using to build our camera system. And whichever modifications we make here, such as setting the Y position just a little bit shorter whenever we save the scene and go back, is going to be updated on this one. Next, I'm just going to position the sun a little more on another place that makes sense. And okay, there we go. So now if we run the scene, we'll be using that camera and the position it has been placed. So let's start by adding some code to this one. So let's go right ahead, select our main camera node and add a script to it, extending the templates we already built for this camera. So let's go ahead and do a create. Now we have a script for our main world scene and a script for our camera, and here you can see the place it has been put in. So now we need to do a couple of things. The first one is to extend this one as a node 3D, so we can get access to all the properties node 3D will bring. So now let's start by setting up the camera, the position we want. So let's go ahead and set up a function that's going to quick start the position of our camera. So let's now build a new private method. So quick explanation about private or public methods. Basically, public stuff you want to be accessible by other objects or nodes, and private stuff you want to keep inside of this one. So we'll be adding a new private method to this one, so it can only be accessible by this script. So Godot itself doesn't have private or public separation for variables or methods, but we will be mimicking this effect by adding an underscore to every time we want to add a private or public methods. So I'll show you what that looks like. So I'll be creating a new function, and this one's going to be called setup camera. And by adding this underscore here for the function name, we will be knowing implicitly, we will be knowing somewhat that this is a desirable private method, so we don't want to be calling this for other objects, and by adding an underscore to this function name we'll have that idea in mind. So it's a workaround around Godot's limitation of not having private control over this. So let's open parentheses here, and we want to set up a camera. So let's go right ahead and ask for the camera as a argument. So now let's add a type here, which this variable is expected as a camera 3D, and this function does not return anything, so void. So the first thing we will be wanting to set up is the FOV of our camera. So let's go right ahead, select our camera and set its FOV to be equal to 10. So setting up the camera FOV is basically like this. So let me just go back to my main scene. Go right ahead and choose it to be editable. So now we can edit this node here with some limitations, of course, because this is a external scene. So as you can see here on the preview, that is what it looks like. And I want to basically be editing the FOV of the camera. So this right here is the FOV, and you're going to see the effect it gives on the camera. So if I actually chose to preview the camera, here we can see more in detail. So as you can see, this is basically increasing the length of the camera. So we'll be putting something very short, like 10. So we'll be accessing the camera, setting its FOV to 10. The next one is setting its position. So we want to set its position of Y to be equal to 3. The next one is set the camera rotation. So we want to set its initial rotation to be -30. Of course, this is not going to work because 30 is given in degrees, and we need to convert this to radians because Godot works with radians. So there's a function for this, which is degree to radians, and this is going to ask us for a parameter, which is the one we want, So let's put minus 30 there. So this line is going to set up the rotation of the X of the camera to minus 30 degrees. And this is very important. We do not want to add the camera Y rotation. So this will be done with the node we actually set up. So this is actually like a mount to the camera. So this will be controlling the Y rotation, and this one will be controlling the X rotation of the camera. So if we go back to our main scene and exit the preview here of the camera, we want to add this camera on its X-axis, this one. And you see the effect it gives on the camera right here in the inspector. So we do not want to be adding the Y-axis. This will be done by rotating the node itself. So this is what this line of code is doing. It's basically accessing the rotation of the camera on its X and changing its rotation there. So the final thing we want is to set the rotation on its Y-axis to be minus 45. Of course, this needs to be in radians, so we need to convert. And this is the Y of rotation at Z. So we now also will be changing the rotation of the node of the camera to be minus 45. So we only these lines of code here. If we run the scene, you now get the camera to be positioned something like this. And it actually did not call the script. So let me just organize this here and explain to you what happened. So as you can see, if we run the scene, the code is not being applied to this camera. So what is going on? Because we have done this as an editable children, it has not been updated. So if we click on this again, it's going to disable editing, which cause all properties of the node to be reverted back to default. And this is also something we want. So now I believe if we switch scenes, you're going to see that the script pop up here. And now the script has been loaded inside the camera. So now if we run the project, you're going to see that the script now will be applied. And it's still not being applied because, of course, I forgot to call this function. So this function, we have defined it here, but it's not being called whatsoever. To call this, we actually need to pass it here on the ready. So whenever the object starts, we want to pass it up. And of course, this script, it belongs to the Rts camera node, not the camera itself. So we also need to add the camera here to be stored as a variable so we can access it. So let me just click here, and actually let me just give here a line. Let me click on the camera, and by pressing Ctrl and dropping down, we're going to be assigned here the camera as a variable called camera 3D once it gets initialized as on ready. So now we could do that, and we can call this function and pass the camera 3D as our setup camera. And now it should be good to go. So now if we run the scene, it should be applied to the script. And of course, we see nothing because it actually worked. But we are very close to the ground, so the camera rotation is being almost close to it. So now the last thing I want to add to this script is to push the camera backwards. So now let's access the camera after we have done all of these rotations, and let's call a function called translate object to local. So what this does is move the object after we have rotated on various rotations. We're going to be translating it based on local space. This is because we do not know exactly the point where we want the camera because of the rotations, because whenever you rotate, the axis rotates as well. So as you can see here by the icon of the camera, whenever we rotate the object, the axis of the object is now pointing there on its local space, not exactly aligned like this one. This is a world object align. So I now want to push the camera backwards because now it has been rotated, but I don't know exactly the position of it. That is why I'm actually doing translate object to local, to move the camera in a local space by a given axis. So here's going to ask us by how much the offset that movement, and we'll be creating another vector tree, which is going to be 100 on the Z space. So we'll be pushing the camera based on this local space backwards by 100. So 100 is a positive value, so Godot, the front facing of the world is actually negative Z, and the positive Z is backwards. So whenever we push the camera by positive information, as you can see here on the Z coordinate, is actually translated on Z. On the world axis, you're going to see that's pushing the camera backwards. So after we have applied the rotations, we're pushing the camera backwards by 100 meters. And whenever we run the scene now, this is the effect it gets. And as you can see, we now can see the floor from a far distance. And something pretty cool, if we go ahead and do a remote here, we'll be accessing stuff for the running scene. And this is what is running actually inside of the game now. And I click here on the camera, you can see that the FOV has been set up to 10. And if I adjust the FOV, here we can see the world we just created. So yeah, this is the effect it gives. So now let's go ahead and add some basic objects to our scene so we can actually see stuff. So I'm going to go ahead, select the world, add some mesh instance, and I'm going to be creating a couple of 3D huts. So I'm going to be using a prism mesh for that. Let's go to its size. Let's set up to be 2 meters by 2 and its size to be 1. And let's push it above ground. So as you can see, this is what it looks like. Let's go to the transform and push it up by 0.5 so it stays put on the ground. So while this hut seems like pretty small, it's actually 2 meters by 2. So our world now is 250 meters, which is somewhat decent for an RTS, just so we have a couple of start. Now let's go ahead, let's translate this position and let's place it someplace here. So let's do like this, and I'm going to be rotating it, and by holding down Ctrl you can snap the rotation to some specific degrees. And I'm going to be pressing now Ctrl D to duplicate this and to just place some more huts here around. So just we have a reference here. So this is the idea. Whenever we navigate the camera, we have some positions here we can actually tell to do a reference work here. So now if we run the scene, we should be able to see some huts here, and as you can see, now it's somewhat more visible. So now let's exit the game instance and let's save the project. So now I'll be going ahead and adding some assets here to make our work a little better. So I'll be adding some grass texture here to our floor, just so we can make it a bit more visible.